Hey all, we Sentinel-5 are here to walk you through Zero Trust powered by Descope, our autonomous multi-agent security middleware for enterprise applications dealing real-time threat detection, automating response, and building user-centric trust. Before we dive into demo, let's see the working of Zero Trust. When a user signs into the Descope authenticated application, all login and API requests are captured by the log detection agent and ingested into Splunk. The analyzer agent reviews these logs to identify potential threats. If a threat is detected, Splunk forwards the event to the alert handler agent, which evaluates severity and takes the right action, such as temporarily or permanently blocking the account, enforcing MFA, or logging the user out. Mails are sent to both the user and the SOC analyst, and users can submit an appeal to request account reinstatement. This is a gist of the entirety of our application, comprising of 6 primary agents, interacting and collaborating with each other via Descope's OAuth and scoped access keys, ensuring secure communication. Without any further delay, let's dive into our first agent, the detector. This is the web interface of our application enterprises who want security middleware onboards into Zero Trust via Descope OAuth. Let's demonstrate this with a bank app, third-party application, that uses Zero Trust by entering their bank's backend URL. They'll receive a proxy URL that'll handle all the logs before reaching the backend. Now, copy the proxy URL and paste it in your codebase. This is a third-party banking application secured with a Zero Trust framework. All activity is logged and centralized in Splunk, including user IP, location, device details, accessed endpoints, and more, giving complete visibility into user actions and potential threats. Let's try an impossible geolocation log and see how Zero Trust responds. The demography between both the logs is physically impossible. How to break this down? Let's analyze this. Splunk allows us to view alert logs, i.e., logs that are malicious and appears to be misuse of our banking app. Let's take a closer look of an alert from Chennai to New York. Let's move to the analyzer agent. The analyzer agents check in real time at varies frequency, high frequency, every 5 minutes, medium frequency, every 30 minutes, and low frequency 5 hours based on the threat type. For example, brute force attack is in high frequency, medium frequency cron is for impossible travel. Low frequency is for data exfiltration threats, etc. For example, let's see how brute force attempt threat is detected in Splunk. It has all the details of the user, the failed attempt count, etc. Let's log in into Zero Trust as SOC analyst. The alerts that we triggered by Splunk on detection of a threat are displayed here. It shows the confidence score and details of the user. SOC analyst can manually block the IP/username after authenticating Splunk alerts through HEC tokens. The alert handler agent applies policy checks to assess the severity of each alert. It first filters out duplicate records, then, if needed, initiates a suspension by sending a containment mail to the user and blocking the user in Descope Management API. The alert handler agent processes incoming alerts, determines the appropriate response, such as a temporary or permanent block, session termination, or enforcing MFA, and coordinates with the mail sender, database controller, and appeal handler. It also creates appeal tickets in the database for user follow-up. Coming to the next agent, the mail MCP. By using Fidata's mail tools and Grok AI's key, customized mail is composed and sent to the user's mail, along with an appeal link to raise a ticket if not guilty. Also, the SOC team receives a mail, stated with the user's credentials. If a user appeals, their alert ID is tagged with their ticket ID, and the SOC reinstates the alert, evaluating the user's subject and content to find if they're guilty. If not, the alerts database is updated and block is removed. Let's see the end-to-end working of Zero Trust. We have a MICT and attacker's automated attacking tool, where various types of attack automatically take place just with a click, choosing from one of these suspicious login attempts. Going with brute force credential abuse, a trial and error password cracking attempt, resulting in multiple failed logins. The Descope authenticates logs, sends them to Splunk, where Splunk detects and password brute force attempts, and forwards to analyzer agent. The alert handler takes ownership of the alert, evaluates its severity, and notifies both the user and the SOC via email. Based on the risk, it may temporarily suspend or block the user. The agent also generates and executes SQL queries automatically to interact securely with the database. Let's find how an appeal looks like. Each appeal is instantiated with the user's ID, with all of its other attributes as null. If the user appeals, the subject, content, timestamp, reason for the mishap will get updated. Now, SOC determines whether to block the user/IP. Now, Let's find the status of the user in Descope. And yes, he is blocked. Z30 Trust isn't just another firewall or a security layer. It's a living system that detects, responds, and restores with fairness, powered by Descope at its core.